weather data project calls for us to use a two-dimensional array in which we'll read data from a comma delimited file in a CSV format, comma separated value. And we're going to read data for a city for all of the weather data for each day of the year. And then we're going to analyze that data. And as a result, we want to find the highest temperature of the year, the lowest temperature of the year, the average temperature for all of the days of the year, the average humidity, the average wind, the annual precipitation for the year, and then how many days was it 100 degrees or above, and how many days was it 32 degrees or below. And we're going to analyze the data for 4 different cities. So Chicago of 2018, New York City for 2016, and notice that's a leap year, so we're going to have 366 days rather than 365. So we want to always bring that into account when we're working with year data. The city of Atlanta in 2016 and the city of Phoenix in 2018. Here's what the data looks like. The first line, these are CSV files, so they're text-based. First line contains the city, the year, and then the third line is the headers of the data. So we're going to have the year, the month, the day, the max temp, the average temp of the day, the minimum temp of that day, the dew point max, the dew point average. So we have data here we won't necessarily use, and the dew point minimum. And then the humidity max, the humidity average. Remember, we want to find the average humidity for the year, so we use that data. The minimum humidity for the day. And then the maximum wind, the average wind, and the minimum wind. So we're going to again use the average wind. And then the barometric pressure, max, average, and minimum, and the amount of precipitation for the day. We're going to read all that data into a two-dimensional array, and then we can cycle through that array to extract the information that we want. So in the instructions, I give a little bit of information on how I created the data. I used Excel. I copied the data from a website, brought it into Excel, and then from Excel created our data files. You will find all 4 data files in our Canvas website. If you go to the module for the assignments, you'll find the weather data assignment, and then here are those 4 CSV data files that you can download and put them in your debug bin folder along with your executable files. They're easy to find. Of course, we're going to use an open file dialog box to locate the file. Some tips here. Your button handler should just be a function to open the data file and read it to populate the class level variables. So we go back and look at, we have this one button we're going to code that's going to get the data from the data files. We're going to put that into an array. It's going to be a type double. We're going to call it weather. And it's a two-dimensional array, so we want 366 rows. That's going to be a row for each day of the year, including the leap year. And then the 19 are the various elements of the data for each day. It'll then call another function to iterate through the data, do the math, and display the results. We need to know how many days there are of the data, so 365 or 366, so we're dividing accordingly to find the average. So make sure you use that, just don't divide by 365, that will throw the data off a little bit during a leap year. And then I use one label to provide for the header labels of my display items. So if we look at my presentation here, all of these items on the left-hand side is one label with just some spacing. And then I have individual labels to the right for the data that will be displayed. We'll want to use a try-catch structure in reading the data, make sure we don't have any problems, there's no exceptions being thrown, and remember to close your data file when you're done reading it. In the instructions, I also give you what the results should be for those 4 different data files. So here's Phoenix, Chicago, New York, and Atlanta, Georgia. So that's our project. I'm going to suggest you pause the video here and do this on your own. And if you struggle, come back and look at my code. Or once you complete it, come back and look at my code and see how maybe I did it perhaps a little bit differently than you did it. So here's the code review for my solution to the weather data project. And I have a form that size is 447 by 490. I basically did that visually, so yours might be slightly different than mine. Gave it the text of weather data analysis, which is label here for just the title, a button that I named BTN Get Data. As I mentioned in the previous in the video, this is just one label, and I did blank lines in between each of the text lines to spread things out a little bit. Each of the displays to the right are labels. So this one's named LBL Location, LBL Year, LBL High Temp, LBL Low Temp, LBL Average Temp, LBL Average Humidity, LBL Average Wind, LBL Rainfall, and then LBL 100 plus and LBL 32 less. You may have named your labels very differently, and that's fine. I just want you to know what my labels are named so you'll recognize those in the code. Let's take a look at the code for this button. So in the directives, I added a system.io so we can open up that data file and read the data from it. I have a string variable called data file, it's going to be the name of my file. I want to keep track of the number of days in that file, whether it's 365 or 366. So I have an integer variable called day count. I set it equal to 0. Then here is my two-dimensional array. It's of type double, and it's two-dimensional, so I have a comma in the brackets. Name is weather. It's going to be a new double, 366 rows and 19 columns. Here then is the BTN Get Data button. All I'm doing is calling a function called Get Data. So here's my function. I'm going to set the day count equal to 0 because I may open multiple files, so I want to reset the data. In a try catch, I'm going to search for that data using an open file dialog that I named OFD Weather Data. I'm going to show that dialog. Here's that open file dialog added to my system. The filter that I set up is comma separated value file star.csv, and the actual wildcard would be star.csv, and then my second pair is simply all files, and I notice I misspelled files there, so let's change that, all files, and it's going to be star.star. Back to our code. So I'm going to open up that file dialog. I'm going to get the file name the user chooses. We're going to use a stream reader to open that data file as a text file. The first line, we're going to read the first line, that's going to be the LBL location.text. So I'm just going to take whatever's in that first line, put it in that first label of location. The next line is the year. So that goes also into the next label here named LBL year. The next line is going to be that string header. And that header is just there for us when we look at the data in a text file. What does it mean? We're not going to use that header file, so I'm going to ignore it, but I need to read it. So it's just sr.readline. I'm putting into a string called header, but notice my comment, we'll ignore that. Then we go through a loop. And we're going to use a loop of while sr.endstream equals false. So as long as there's more data to be read, we'll continue this loop. I'm going to read the line, and since it's comma delimited, comma separated value file, I'm going to split it on the comma and place that into a temporary string array called XYZ. Remember, this is string data, so it's going to be read in as strings. Put it in a string array, separating it by the commas. Then I'm going to do a loop, a nested loop for int I equals 0. I'm going to do while I is less than 19. So I is going to go from 0 to 18. We have 19 elements in our data. We'll increment I each time through. Then the weather row day count, element I, that's my second element of my 2D array. I want to parse XYZ of I, that was our string data, as a double value. That's going to populate those 19 columns. In essence, we think of this as a table of each row. Then we're going to increment day count so that each row is going to get incremented. So each row represents the various days of that data file. See, I had a commented message box here where I was just using that to check to make sure things were coming out as they should. Want to close my file. Now I've read all that data into the data array. Now we need to analyze the data. And we're going to call another method. I called it showWeatherStats. Here's my catch on that exception. So if something goes wrong, we'll have a message box saying something went wrong and provide the message of that exception. So here's my showWeatherStats. So I want a string array of all the months. I'm going to ignore element 0 so that element 1 is January, element 2 is February, and so forth. I'm going to use this in displaying what day the hottest day was and what day the coldest day was. I'm going to set my low temperature to 1,000 degrees. And I'm going to set my high temperature to a minus 1,000 degrees. So we know those are going to be overcome. My low temp day, if we only had one day, would be January 1st. And I put in the year of 2018. In reality, we'll use the year that we get from that second line of our data. But we know this is going to change. We're not going to have any 1,000 degree days or any negative 1,000 degree days. I'm going to have my averages for average temp, average humidity, average wind, and the precipitation all set to 0.0. Notice these are double values. And then the number of days above 100 and number of days below 32 are both set to 0. So those are my counters that I'll be using. Then my for loop. We're going to go through our data with I equaling 0 as long as I is less than day count. So if it's 365 or 366, since we're starting with 0, we'll go to 364 or day 365 on a leap year. And each day then we're going to get the information from that day and see if weather element I, that's row I, that's our day, whatever day we're looking at, element 3 is our high temperature for the day, is that greater than the high temp? Now we know the first day is going to be greater than a minus 1,000 degrees. So that first day's omelet going to kick in as the highest day, and it's going to potentially increase on several of the days. And when it does, we're going to set the high temp to whatever the element is of I, 3 of weather. And we'll set the high temp day to the months, and we're going to get the integer value of weather I, 1. So that's going to give us then the month from this array, plus we're going to get the day, that's our second item, and the year. That was our very first item, element 0. We're going to do the same thing for the low temp. If the low temperature that day is lower than our low temp, we want to record that temperature as the current low temp for the year and determine what day that was on. We're going to increment the days 100 if the high temp is greater than or equal to 100. So we're going to do a plus equals, and I used a ternary statement here of either adding 1 or 0. Do the same thing for day 32, plus equals. We're going to get our low temp of being less than or equal to 32. If it is, we'll increment it by 1, otherwise we won't increment. The average temp, we're going to add that average temp for the day to our average temp, add the average humidity, and add the average wind. So you can see here the elements we're getting are column index 4, 10, and 13. Remember, we're bringing a lot of data. We're just reading in all that data, but we're not necessarily going to use it all. We don't really care what the barometric pressure is for this particular application, but we'll store that data temporarily in our array. Same thing with precipitation. That's going to be element 18. That's the very last element of our 19 elements, going from 0 to 18. So now I have the total for the year of the average temp, the humidity, the wind, and the precipitation. I know how many days are 100 degrees or more, how many days are 32 or less. I know what the high temperature is and the low temperature is and which days those occurred. What I need to do now is take those totals of the average temp, humidity, wind, and divide those out by the number of days that we have in terms of the year. So I'm going to display these in our labels. So here's the high temp, the low temp. For the average temp, I'm going to take the average divided by the day count. I went into the character map and found the little symbol for the degrees. So it's the degrees, and these are in Fahrenheit. So degrees Fahrenheit on, and the temp, the day. Same thing with the low. The average temp is also going to be degrees Fahrenheit. Remember, we're dividing by our day count. I'm going to convert that to 2 decimal places. So I'm using the toString N2 modifier. Average humidity, same thing. Going to divide by the day count. Here, humidity is in percentage. Average wind, again, divide by the day count. 2 decimal places, and it's going to be miles per hour. Total rainfall for the year is in inches. And then we're going to display the number of 100 degrees days and 32 degree days. That's my solution. Let's watch this run. So I'm going to get the data. And let's just do the Phoenix data from 2018. I can see my data file. I'm going to say open. And so in 2018, the highest temperature was 116 degrees on July 24th. The coldest was 36 degrees on December 29th. Average temp for the year was 76.5. Average humidity, 32.05. Average wind, about 6.5 miles per hour. We got a little over 8 inches of rain. 118 days at 100 degrees or more, but we had no days below 32. Again, our lowest day was 36. Let's look at another day. Let's look at Chicago for 2018. A little bit different data here. Our highest temperature was 96 on May 27th. -9 was the low on January 2nd. Average temp 51.95. Average humidity 69%. A little windier in the Windy City than it is in Phoenix, so 9.75 miles per hour. 32.5 inches of rain, a little more than that. No days above 100, but 122 days at 32 or less. So that's your project. I hope you enjoyed this. If you just jumped into this video, you can see all the videos from the C# Xamarin Programming Cohort playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos that I create, you can click my picture up in the top right and subscribe to the channel.